Bismillahirrahmanirrahim. In this session, we will discuss the area of the region bounded by a line and the curve. So this is a line and this is a curve. So we'll discuss this kind of curve area, enclosed curve area by the line and the curve. So let's start this exercise 15.11. Find the area of the region enclosed by the curve. This curve and the line. This is line y equal to. So we have to find the area of this region. So secondly, the area of the region bounded by the curve this and the line x is equal to 2 and y is equal to 2. So we have to find this region. So similarly, we will solve this kind of problem. So let's start this one. Area of the region bounded by a curve. So we have this 1 plus cos x, y is equal to 1. So 1 plus cos x is equal to 1. So y is equal to 1 and y. So this is a line and this is a curve. So from this we have cos x is equal to 0. So x is equal to minus pi by 2 to plus pi by 2. So this is the area minus this area. So we are integrating this function, this minus this, and we have obtained this. So substituting the value, we have obtained this result. So this is question number 1. Now question number 2, the area of the region bounded by the curve this and the line this and this. So this is question number 2. Y is equal to 2 plus 3x minus x square, and here we have 0 to 2 and this 2 dx. This is y dx. This is y dx. Y dx from 0 to 2 and then 0 to 2 y dx, and y is equal to 2. So this is y is equal to 2 dx. Is a constant line. So on substituting or integrating this, we have obtained this. We have this and this. Substituting the limit, we have obtained the result as this 3/1/3. Let's solve this question number 4. Find the area of the shaded region, this region. So this is a line and this is a curve. So it's 2 sin 2x plus 3 cos x, and here we have this limit. So this area, so we'll take this area and subtract this area. So we have two areas. This curve from 0 to pi by 2 and then 0 to pi by 2 for this equation. So question number 2 solves this one. So this is very important. So keep in mind this function and this values. Question number 14. So here we have question number 4. So we have shaded region, this function 0 to pi by 2. So we have obtained this limits area, and then we subtract this area to the shade white region or equation of line. So we have this equation of line. For this equation, the equation of line is minus 6 upon pi x plus 3. This is just substituting this equation. So here we have pi by 2 and 0. Here we have 0 comma 3, and substituting the line equation here, y minus y1 is equal to y2 minus y1 divided by x2 minus x1 bracket x minus x1. On this basis we can obtain a simple line equation, and from that line equation take this area and then subtract this area. So this area and then subtract this area. Substituting this value, taking integrals, this integral, and the limits from 0 to pi by 2, and we have obtained this result. This is the result. This is a very important question. Now sketch the following curve and line and find the area enclosed between their graph. So this is also a very important question. So we have y is equal to x square plus 1 and y is equal to 5. So this is y is equal to 5 and this is parabolic shape. Y is equal to x square. We have already drawn it in earlier exercises. So from this is y, this is y, so both are equals, so we have obtained. So this intersecting points we have obtained. This is plus minus 2, this is plus 2. So we are integrating it from minus 2 to plus 2, and this is the region. This is 5 dx, this is 5 dx, this region, and then subtract this part, subtract this part. So this is x square plus 1, and the limit is from minus 2 to plus 2. So we will have this area and this total area, and then this area, subtract, we will get this shaded region, total area of this region, and then we will have this region shaded area. So we have 5 dx minus this, and then this area is here, subtracting, and from this we have integrating this part, substituting the limits, and we have obtained this result. This is very important. And in a part B we have this function and x plus y equal to 9. This is the area, this is line equation, and this is curve. So we have drawn this curve, this is line, and from this we have this intersecting points, and this is from this intersecting points we have minus 2 here, and this is 3. So minus 2 to 3. So we have this area, and then we have this area, white area, so we'll have this area. So we take this area from here by integrating, and then we take this white area, subtract from this overall area, we will get this shaded area. This is the idea that we are using in every problem here. So from this area we have this equation, line equation, and this whole area is integrating to obtain this by this part, and then this curve region is subtracting here from minus 2 to plus 3, and then we will obtain the difference is obtained in terms of this shaded region. So integrating this part is this, integrating this part is this, substituting limits, and the rest is just the manipulations or algebra simplifications. Simplification, we have obtained this. So this is, the idea is simple, the idea is not very difficult, but this simplification is also not very easy, because everyone has to solve it very carefully to get a correct numerical result. So this is part. Yes. Another question is this: y is equal to x4 and y is equal to 1 over 2x. So this is the line equation and this is the curve. So this curve is this and this line equation is this. So we have to find the shaded region by this curve and line. So first solve this, equating each other, and we have this 2 value, x is equal to 0 and 4. X is equal to 0 to 4. If we take this region, integrate this curve region, first subtracting this white region, we'll get this. So curve region will appear first, and then this line equations here, and then take the limits here. On simplification, you will get the result. So this is the root x minus half x. Integrating this and substituting limits, we have obtained this. This is this region. So let's solve this part D. Here y is equal to 4x minus x square and y 2x plus y is equal to 0. So this is a line equation, 2x plus y is equal to 0, and this 4x minus x square is the parabolic shape. This one. So and another from this equation we have right there. So y is equal to minus 2x. So on equating this together, because y is this and this line equation this, so simultaneously on solving we can get the intersecting points. So we have intersecting point x is equal to 0 and x is equal to 6 here. Here we have this region, and here we have this region. This is a bit tricky one. So we'll apply this 0 to 6 limits, and the curve is first, and then subtract this region. So this region will cancel. This is white region, because we are taking the integrals from here to here, and then subtract this white region. We will get this shaded region. So the square region from here to here, this whole region is this part, and this white region is this part. So, and the difference is this shaded region. This is the difference. So we will solve it, and on solution we have obtained this. So the shaded area is because the area always appears in positive terms. So this is 36. Similarly, this part E. Let's solve this y is equal to x square and y is equal to x 2 minus x. Here we have two curves. This is this curve and this is this curve. This is very difficult because this is x0 and this is x equal to 2. So from this x square is this one. So intersecting at 2 points. So on equating, and we have obtained x is equal to 0 to 1. So this is 0 and this is 1. And substituting this shaded region, so we have this region and then this curve. So the first of all this curve is this one, this area, and then subtracting this white area will appear this one. So this area function will appear first, and then this area is this here. So shaded region is this. This is the most important part. If we can draw this figure, we can estimate it. The rest is the simple simplifications. We have obtained this one. Similarly, this y cube, y is equal to x cube, and this is quadratic. So here we have a cubic function and have a quadratic one. So this cubic function and a quadratic. So solving this, we have 3.04 and -1. So -1 to 0, this is -1 to 0, this region, and then this second area is this. So we have these two areas here. This is important, this is most important part. So we will solve only area 2 is considered here. Since x is greater than 0, so a shaded area is this part. Area 2, area 1 is not covered because the x is greater than 0 is given in the problem. For this problem, this is given, this information is given. So we will take this area 2 only. Similarly, this part 7, this is a curve and this is a line equation. So this is line equation and this is a curve. So we have to draw this curve and this is line equation. From this we have obtained these intersecting points is x equal to 4 and this is 0, and area 1 and area 2. So this is area 1 and this is area 2. So we'll add these two, area 1 plus area 2. So this is simple line equation from 4 to 10, and this is 0 to 4, this curve area. This is very important. Rest is just a simplification, so just substituting, and we have obtained this. Now question number 8. We have this curve, and we have to differentiate this one. So this is a tangent point. So on differentiating this, dy by dx, we have at x is equal to 2. So this is 2. So we have obtained a slope, this gradient, and from this gradient we have obtained a line equation. So line equation is obtained. We have to obtain the area. So this area from here to here, this area, and then this area. This is very easy. On solution we have obtained the result. So this area minus 2 to 2, this area is, and then 2 to 6 is a curve area. This is basically the part. If we can draw this one, we can solve this. If we can't, we cannot do this. This is the important area. The rest is just a simplification. Similarly, this part and other parts. Question number 10. Here we have y is equal to 2 plus cos 2x and y is equal to 1 plus 2 cos 2x plus this. So we have to draw this 2 plus cos 2x and 1 plus cos 2x. This curve from 0 to pi. So 2 plus cos 2x, this region, minus this curve is this covered region or enclosed region is obtained. And integrating we have obtained this. This is the important part. If we can draw this, we can easily solve. So this function is basically this part. So we have this overall region, and then we will draw this region. This whole region from this curve, initial curve, from this whole area under curve, and then this region, this part, we subtract this from whole region to this white region, we will get this shaded region. This is here, and on simplification we have obtained this. The question is very easy, but the understanding is not as much easy unless we spend some time with this kind of problems. So in the next session we will discuss exercise 12.12.